right, so video 2 for today. We are solving exponentials and logs. So we're going to be solving exponentials, we are going to be solving when we have logs, and then we're going to be solving the word problems using logs. So let's start looking at this. So first part of this foldable, solving exponentials. We are first going to get the b by itself. So that means if we have an a, we need to get rid of it. If we have a k, we need to get rid of it. The h is kind of attached, so we can't get rid of the h. But we need to get the b, the part that is raised to the exponent. We need to get that part by itself. Step 2, we're going to use the e to convert it to a log, because we can solve logs now that we've done change of base. And then we're going to use change of base and solve it. Everything day 1 and now first part of day 2 coming together to solve. So first example, I have 4 to the x is equal to 20. Do I have anything outside of my exponent? No. The only thing that's there is the 4. It's attached to the exponent. I can't move it yet. So I'm going to do the e to rewrite it. So this is going to be log base 4 of 20 is equal to x. Again, you start with the base and you do your e, and that tells you the order that it is. So log base 4 of 20, I can use my calculator to do that. So that is log of 20 over log of 4. Use my calculator, and I get that that's approximately 2.161. Okay. Next one, 6 to the x plus 3 is equal to 24. I have a plus 3 outside of that exponent. I need to get rid of that plus 3. How do you get rid of the plus 3? U minus 3. So you have 6 to the x is equal to 21. There's nothing outside of that exponent, so now I'm going to do my e to rewrite it. So that is log base 6 of 21 is equal to x. I can do log base 6 of 21 in my calculator using change of base. And I get that that's approximately 1.774. The next one, there are some things outside of my x, but it's attached to my exponent. So I can't move that 1 because it's part of the exponent. The b is by itself. There's not an a out in front, and there's not a k. That's an h. I can't do anything with the h yet. So I'm going to rewrite it. So this is log base 1/2 of 27 is equal to x minus 1. Again, if you do your e, you started with the 1/2, you got to the 27, and then what it equals is the whole exponent. It's just there's more to do with the exponent this time. So my exponent is x minus 1. I'm going to change of base the log of base 1/2 of 27. So you have log of 27 divided by log of 1/2. When you put that into your calculator, you get that that is negative 4.755 is equal to x minus 1. I'm still trying to solve for x, so I'm going to add 1 to both sides. And you get that that is approximately negative 3.755. This last one, I got to get b by itself. B is the part that's in the parentheses. So I do have a 3 that is in front. I have an a that I don't want there. So how do you get that a? What is that a currently doing? That a is currently multiplying. So how do you undo multiplying? You divide both sides by 3. So you get 3 to the x is equal to 81. I need to get the exponent down, so I'm going to e it. So that is log base 3 of 81 is equal to x. Using log of 81 over log of 3, that's a nice number. X is equal to 4. So that is part 1, solving exponentials. Solving for when x is part of my exponent. So now let's talk about solving logs. We're going to use the e to convert it to an exponent. We're either going to calculate or use opposite operations to solve. Also important is to get the log part by itself on these as well. So just like the ones above, you have to get the exponent by itself. Here we've got to get the log part by itself. So my first example, log base 5 of x is equal to 4. My log is by itself. There's nothing in front. There's no k in the back. There's no a or k. I can go. So I'm going to e it. So that is 5 to the 4th is equal to x. And therefore x is equal to 625, just using my calculator, 5 caret 4. This second example, my log is not by itself. I have a 2 that's being multiplied in the front, and I have a minus 1 at the end. So I need to get rid of those first. So again, you have to think, which one goes first? The multiplying by 2 or the subtracting 1? Which is further away? because you're gonna work your way out to in, which is further away. That 2 is right up next to it. It is multiplying by it. That is next to it. That is not what's going to go first. That 1 at least has an operation in between, so we're going to get rid of that -1 first. So we're going to add 1 first. So we're going to get 2 log base 6 of x is equal to 4. Again, my log base 6 is not by itself. Still have that 2 out in front. So I'm going to need to divide by 2. So I have log base 6 of x is equal to 2. Now my log base 6 is by itself. I'm going to e it out. So I have 6 squared is equal to x. And so x is equal to 36. All right. Now, difference between the first 2 and the last 3 is now instead of solving for my argument, now I'm solving for my base. So I have x, my log is by itself, so I have x squared is equal to 15. Now this may look like, wait, how do I solve this now? How do you undo a square? You take the square root. So I square root both sides, and then you approximate. Okay, so that's approximately 3.873. Same idea here. I'm going to do the e. So this is x to the third is equal to 243. How do you undo cubing something or raising something to the third power? You take the cube root of it. So that is approximately 6.240. The very last one, there's nothing outside of log base x. So I'm going to e it. And so that is x to the third is equal to 27. Cube root both sides, and you get a nice x is equal to 3. So we have talked about solving exponentials. We have now talked about solving logs when your x is your argument or part of your argument, and also when x is your base, because you kind of treat those a little bit different. The idea is the same, but the way you go about solving them is a little bit different. Let's talk about word problems. So first thing you're going to do is you're going to write the equation either using option 1 or option 2. Option 1 and option 2. That goes back to last unit. So do your time frames match? That's when you use option 1. Do your time frames not match? That's option 2. Then you're going to get the b by itself, exactly like what we did with exponentials before, because at this point what we're doing is solving an exponential. You're going to use the e to convert it to a log, and then use change of base to solve it. So here's the first equation. You open an account with a 5% annual interest rate with $500. So you're starting your account with $500. How long will it take you to have at least $1,500 in the account? So what we're trying to find is the time. Time is that exponent. So that's what we're solving. We're solving for the exponent. So this is option 1. My time frames match. I'm assuming I'm talking years because I'm not specifying years or months. It says annual interest, so that's years. And it doesn't say how many months, so I'm going to assume we're going with option 1. So filling in with what I know my starting amount is 500. 1 plus, because I'm adding interest, 0.05, that's 5%. I'm raising it to the t because that's what I'm trying to find. And I want to know, when does that equal 1,500? So now I'm trying to solve for t, meaning I need to get the exponent part by itself. That exponent part has a 500 out in front. That 500 is currently multiplying. So how do I undo multiplying? I divide by 500. And I get that is 1.05 to the t is equal to 3. Now how did I get 1.05? I added 1 plus 0.05. Okay. Now my b is by itself. My exponent is by itself. The only thing I have is the base and the exponent. So I need to do the e to rewrite it as a log. So that is log base 1.05 of 3 is equal to t. I do change of base, and I get that is approximately 23 years. It's a rounding, but it's approximately 23 years. So in 23 years, with a 5% interest, I will have saved $1,500. Okay. Next one. You are decreasing your debt by 10% each month. How many months will it take to pay off the debt to a penny? Okay. Because I can't pay it off to 0 because exponentials can't equal 0. So how long would it take to pay off to a penny? So 30,000, this is option 1 because again, we're talking months and months. So my time frames match. So I'm using option 1. So 30,000, 1 minus 10%, okay, decreasing means minus, to the time is equal to 1 penny. So I go ahead and combine 1 and 1 minus 0.10. So I have 30,000 times 0.9 raised to the t is equal to 0.01. I want to solve for t. I need to get t as much by itself as I can. So I need to get rid of that 30,000. So I'm going to divide by 30,000 on both sides. So I get 0.9 to the t is equal to 0.01 divided by 30,000. Don't worry about what number that is. It's a big decimal. Don't worry about it. Just leave it as a fraction. I'm going to e it. So I have log base 0.9 of 0.01 divided by 30,000 equals t. Thank goodness we have these calculators, right? Because that's a lot happening. So that is log of, yes, all in one parentheses, 0.01 divided by 30,000, close that parentheses, divided by log of 0.9. Again, let this calculator do all of that thinking for you, and you find that that's actually 142 months. So if you want to think about how many years that would be, 142 divided by 12. So you're talking almost 12 years for you to pay off 30,000 if you're paying off your debt by 10% each month. So we have talked about solving exponentials, we've talked about solving logs, and then we've talked about solving word problems that involve exponentials, and in order to solve the exponentials, we use logs. So that is solving.